Okay, we're going to have a look at probability, which is all about working out the likelihood of something happening. What's the chance it will rain tomorrow? What's the chance of winning the lottery? What's the chance of winning a game of cards? Okay, so we're going to have a look at three things. We're going to have a look at the probability scale, calculating simple probabilities, and comparing likelihoods. Okay, so the probability scale demonstrates the different values that a probability can take. Probabilities can range from 0 all the way up to 1. If something has a probability of 0, we would say that that is impossible. Okay, for example, if today is Monday, it is impossible that tomorrow is Thursday. The probability of it being Thursday tomorrow is 0. If a probability has got a probability of 1, it's absolutely certain. If today is Monday, then tomorrow is Tuesday. If you roll a 6-sided dice, you're going to end in a number 1 to 6. That's a guarantee. If we have a probability of a half, that would be an even chance. The further along this scale that we are, the more likely something is to happen. I'll just put more likely. Whereas if we were to go the other way, it would be less likely. Probabilities can be represented in multiple ways. They could be represented as fractions, as we see here, but these could also be represented as decimals or as percentages. Both give us a good idea of the likelihood of something happening in relation to the whole. For fractions, a whole is 1, and percentages, a whole is 100%. So what we're doing is when we're working out a probability, we're kind of trying to place that fraction on this scale to try and determine whether something is more likely or not. So we're going to have a look at how to calculate simple probabilities. And essentially to calculate a probability, I'm just going to write a little formula here. The probability of something happening, this is a really long formula here, is we've got the number of favourable outcomes over the number of possible outcomes. Which is very, very wordy, but what I like to say to pupils is I just like to tell them, okay, make it into a test score. Okay, so if we make it into a test score, we can hopefully quite easily identify what the probability is. So let's work out the probability. So we've got 10 numbers here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's figure out the probability of choosing an even number at random. So we look and say, okay, well, how many even numbers are there? We have got, I'll make that smaller. We've got 1, 2, 3, 4, 5. So we're going to have 5, and that's out of 10 altogether. Okay, so do you see what I mean by like making a test score? 5 out of 10. And in this case, if ever we deal with a fraction, if we can simplify it, we simplify it. Both in the 5 times table, that would simplify to a half. Let's look at doing the probability. Let's say all these numbers were put into a bag and we wanted to choose one at random. Let's say, what's the probability of choosing a number bigger than 3? Okay, so we'll look at this here and we'll say, okay, well, how many of these are bigger than 3? So for us, it'll be all those ones there. So there's 1, 2, 3, 4, 5, 6, 7. So we would have 7 out of 10. Just one wee thing to comment here. If it's 7 out of 10 for being bigger than 3, it would be 3 out of 10 for being less than or equal to 3. It's really important that we appreciate that the probability of an event happening plus the probability of an event not happening equals 1 whole. Okay, so for example, if we think about this in percentages, if there's a 40% chance it will rain, there will be a 60% chance of no rain, because these two values would sum to 100%, which is a whole. we could think about this in another way. Remember I said probabilities could be written as decimals. So let's say that there's a 0.2 chance of winning a game. If there's 0.2 chance of winning, that means that there's a 0.8 chance of losing, because these two values need to add up to a whole. Okay, so here the whole would be 1. If we did it in terms of fractions, if we had a 5 out of 7 chance of success, then there would be a 2 out of 7 chance of no success. Because these two numbers need to add up to a whole, and here a whole would be 7/7. Okay, 7/7 would be a whole there. So it's really, really important, this little wee section here, that probabilities need to sum to 1. Okay, of all the possible outcomes. All the possible outcomes need to sum to 1. Okay, let's have a look back at our examples. Let's do another one. Let's do the probability of choosing a prime number. So once again, it's going to be out of 10. Let's have a look at how many prime numbers are there. Okay, so we've got 2, 3, 5, 7. So we've got 4 prime numbers. So that's going to become 4 out of 10, which can be simplified to be 2/5. So there's a 2 in 5 chance of choosing a prime number. There's a 3 in 5 chance of it not being a prime number. The last thing we're going to have a look at is comparing likelihoods, because yes, it's all very well and good of saying, okay, that there's a 2 in 5 chance, but can we place that on our probability scale? Can we say if that's likely or not very likely? So to finish up with, we're going to have a look at how to compare likelihoods. Just one really quick example. So we've got 2 scenarios. So scenario A, rolling a number bigger than a 9 on a 12-sided dice. Or scenario B, that a month will end with Uary. Okay, so which is more likely? Justify your answer. Okay, so let's have a look at this. Actually, I'm going to change this dice number. I'm actually going to change it to be like a 15-sided dice, just for the sake of the question. Okay, so rolling a number bigger than a 9. So I'm just going to put P bigger than 9. So there's 15 sides altogether. So we're going to have bigger than 9, so we've got 10, 11, 12, 13, 14, 15. So that's going to be 6 out of 15. They're both in the 3 times table, aren't they? So that's going to become 2 out of 5. Okay, so there's a 2 in 5 chance of getting a number bigger than 9. Let's have a look at the second one. Scenario B, the probability that a month will end with Uary. Let's put this here. So there's 12 months altogether, so it's going to be out of 12. So we've got January, February, March, April, May, June, July, August, September, October, November, December. Oh, so there's just 2 of them. Okay, so it's just 2 in 12. So that can be simplified to 1/6. So see if we have a look at these 2 answers, can we say definitively which one is more likely than the other? So essentially this boils down to this calculation here. The calculation is 2/5 versus 1/6. And whilst this might not be too terrible, the problem is it's hard to compare fractions that are named differently. Here our fractions are named as 5ths and 6ths. If they both had the same name, like for example if it was 3/10 and 4/10, if they had the same name we could easily compare them. So what we're actually going to do is we're going to have a look at our denominators and think, okay, what's the lowest common multiple of 5 and 6? And I think we should actually find the lowest common multiple is 30. So we're actually going to change these to be out of 30, and then we're going to be able to say definitively which one is better, or which one is more likely. So to get from 5 to 30, we've times by 6. So I'm going to do 2 times 6. So a 2 in 5 chance is the same as a 12 in 30 chance. To get from 6 to 30, I've times by 5. So I'm going to do 1 times 5, which is 5. So if we have a look now, we're comparing scenario A and scenario B. Well, scenario A has a 12 in 30 chance, scenario B's got a 5 in 30 chance. So we would say scenario A is more likely. More likely, since 12 over 30 is more than 5 over 30. If we think back to this example here, when we got the chance of it being prime, which is 2 out of 5, it's really important we can place that on a probability scale as well. So I'll just write it down again. So prime was 2 out of 5. So where would that go on this scale? The only reference point we have is a half. So maybe it's better to think about is 2/5. What is 2/5 compared to a half? So we've got 2/5 and a half. Well, once again, if we do something similar and we get them to have the same denominator, the denominator is going to be 10 here. So 1/2 is the same as 5 over 10. 2/5 is 4 over 10, which is less than a half. So the probability of something being prime for that list would be just less than a half. Maybe I could put that there. So it's less likely, just less than an even chance. Okay, so there's a few wee quick examples on probability at level 3. Thanks very much.